Welcome to the oldest working computer. The honesty and slightly unfortunately it's not working today. We have the temperature, the heat doesn't help it at all. The circuits actually move up and you can't get good switching points. And bizarrely the valves here get affected by the light, so it becomes a bit of a game to try and keep the light down. So apologies, you won't see the oldest working computer working. The whole Dekatron. So after the Second World War we had order mastering set up to look at nuclear energy for bombs, military uses, and Harwell set up for energy uses. And they started working on the Magnavox nuclear reactors, so that's where their work was. It obviously involves a lot of calculation to work out how you're going to build a reactor, how big you're going to build it, how big your carbon rods are going to be, metal and the whole lot. So what they would do is young graduates would come out of university, and gosh, haven't we seen one of these before? Haven't we seen one of these before? You seem enthusiastic about them. So they gave the young graduates these and said, off you go, start calculating. I don't know about you, but I wouldn't be enthusiastic. But the important thing was some of the calculations had to be right. So you'd have to get two people to do the calculation. And if the two didn't agree, you'd have to get a third person to do it. So it's not exactly a fast process, nor a particularly satisfying process. So a guy called Ted Yarber said, about 53, he said, look, I need a machine to do this. He was aware of computer developing. Talk about the other machine, the other side, so he was getting into the public domain. He said, look, I'm going to build a basic computer. The rule was he had a certain amount of money, but it had to use standard components available. So he said, look, what I'll do is I'll build the memory, which is this bit across here, almost from that corner to that corner, to here, out of something called Dekatrons. Dekatrons you may have seen in guide counters, where you look at it and so the sensor stops, and the great thing about this, you can use it to count by 10, because there are 10 pulses that come out of it. They'll stop at a particular point, and when I release it, it will go around and give me that number of pulses. So it was a very cheap way of making memory. The slightly awkward thing, which I never quite understood, you'd have to take the binary input, convert it to decimal, and then be able to show it. So that struck me as a bit awkward, but not great. Input of the program was through a tape reader. Now remember, I got excited about Colossus, which had an optical tape reader. Because that knowledge didn't carry on after the war, real shame, these are mechanical tape readers, so they read them very slowly indeed. You take your program, you would load it into the memory, load in your data, and then run it. The machine is actually, as you can imagine here, the power supply. Mains driven anything between 50 volts, 250 and up to 350 volts to drive the valves. This is the arithmetic processing unit. Mix of valves and relays, predominantly relays. And here we have, as I said earlier, the memory. And here, sorry, I didn't bother, it wasn't working, there were two accumulators. And what you'll do is run the program and see the results of the accumulators here. No, question.
So is it the oldest working in the UK or the oldest working
in the world? How much memory do you think I've got?
Kilobyte?
Good guess, too much. 330 bytes. I had data bigger than that. I mean, you just think, good gosh, how could I actually done anything with that? Absolutely stunning. But these were the early days. When you look at the code, and I think there's an example code, it almost reminds me of machine code, mnemonics type machine codes, where you're actually starting to build the language in that one. So it really is almost down to that primitive level. If any of you guys have done microprocessor or otherwise, you'd recognise some of the load of memory instruction, shift of memory instruction, shift again, shift out of memory instruction. So it was really quite fundamental programming you doing this one. This ran, and the big thing is they did a little test, and they got, I think Ted Yarber himself actually sat there with a calculator, worked for a while. He carried on running about the same speed as the machine for about half an hour. With some this for a while. I went for a toilet break or a cup of tea. Of course the machine carried on running. And that was the bonus of it. It could run and keep running. About 4 operations a minute. There's a fact we have in the guide, the volunteer's guide, and I'm going to give you the fact as information, so you may be interested in this one. If you ran your iPad 2 for 1 second, and they gave the same instructions in Harwell Dekatron, it will take about 700 years for Harwell Dekatron. I don't quite believe that now. I think there's something slightly wrong, but whatever. It will probably take into tens of years, or probably even touching 100 years maybe, because the instruction sets change, memory changes. It's not an ideal comparison, but the way I look at it is where you can log on, if you worry about getting onto your web page in one second, this thing will take you a little bit longer, so you wouldn't go surfing the web with this. You'd be very old afterwards. So it ran until about 1950. They had the brilliant idea to say, look, people getting interested in computers, education establishments were starting to offer computer courses, so they offered up for raffle and said, whoever wins the raffle can have this as a teaching aid. Wolverhampton won it, which is where it gets its name. They didn't like the name the Harvard Dekatron, so they renamed it the Wolverhampton Institute of Technology, Computer from Harvard. Now, someone once said it was a good thing Birmingham didn't win it. One you probably would have been called that no end as well. One of the things that's very important here is we do a bunch of teaching and the like, and we try and raise some sense of awareness. This is an interesting photograph of about 63 of the class who actually use this machine at Wolverhampton. You'll notice the gender mix is about 50-50. And one of the things we're hugely aware of getting women involved in computing and the like, and you'll see us talk about women's contribution to computing. What was interesting, when we finally got it back and restored it, we managed to find all but one of the class some 70 years later. In terms of his life, it worked for Wolverhampton for probably into the 70s. They then passed on to the Birmingham Science Museum, who ran it as a working display, and then it failed and got hidden in the stores. One of our trustees who happened to be around there saw this front panel. That's interesting. So we came to a deal with Birmingham in that if we could have the machine on loan as long as we got it back and got it working. Oops. But it took about two guys about 3 years to get it working. They actually went round and did every single joint, pulled every single item out. And actually only had to add one extra capacitor, which I think is absolutely amazing to get to the point where it's working. So, stunning bit of history, back in the Guinness Book of Records, absolutely working. It only takes about 3 and a bit kilowatts. It's quite portable at about 2.5 tons.
Portable.
But not great for web surfing.